Hello, welcome back to our channel. Today we are going to discuss about dual nature of radiation and matter. It's very simple chapter and don't leave both MPC and BPC. Compulsory one question is coming from this chapter for MSET as usual for NEET. Come to our point. Before 19th century there is we don't know about the electron, proton and neutrons. What they were thinking, atom is the smallest particle. But after 19th century they have given that yes, we can split the atom. Inside the atom elementary particles are there. You know that electrons, protons and neutrons are the elementary particles. But the journey was starting with at high potentials and low pressures all gases are discharging the electrons. Suppose at normal temperatures, normal potentials and normal pressures, what happens? All gases are behaving like bad conductors. Means there is no available of the free electrons. But whenever we are taking one gas, suppose this is the discharge tube you should consider. So inside the discharge tube you are taking the gas and you are providing the high potential and low pressure. Then these are the releasing the elementary particles. They said that those are having the negative charge and those are negatively charged particles, and they have given that nothing but cathode rays or electrons also we are calling. So later they have done many experiments and they have given charge of the electron is 1.6 into 10 to the power of minus 19 coulombs. See, specific charge of the electron. Specific charge of the electron means ratio of charge to the mass is how much? 1.76 into 10 to the power of 11 coulomb per kg. Like that, mass of the electron is 9.1 into 10 to the power of minus 31 kg. Later they have done one more experiment, Division and Germer experiment. See, wavelength of the electron is 12.27 by under root V. V belongs to potential. So you should express, otherwise under root 150 by V angstroms. So like that they have started after 19th century, and from the Millikan's oil drop experiment they discovered the charge of the electron, and from the J.J. Thomson effect they discovered the specific charge of the electron. And when you know the E and E by M, then easily we can find out the mass of the electron. So like that they have started and they have done many experiments like that. But the main concept from this chapter is the photoelectric effect. What is the photoelectric effect? It is giving the proof that matter is having the particle nature. And previous many people they said matter is having the wave nature. So like that it happens in this chapter only. One scientist, Broglie, he has given that clarity. Matter is having both wave nature as usual, particle nature. That's why this chapter name is what? Dual nature of radiation and particle. When the particles are moving, it behaves like particle as usual like wave. That's why this is called the dual nature of radiation and matter. Anyway, come to our point. What is the photoelectric effect? When radiation or electromagnetic rays falls on the surface, see here we are taking one discharge tube. Inside you are taking, this is the emitter and this is the collector. Mostly we are using, this is like photosensitive metal. Means when light falls on that, easily electrons are liberated. Those are like sodium, potassium, lithium, cesium, like that we are taking. Anyway, how to do this experiment? See, this electromagnetic radiation or monochromatic rays falls on the surface through the window. Then the electrons are liberated from this. Then these are moving towards the collector. Flow of the electrons is giving the current. This effect is called the photoelectric effect, and these electrons are the photoelectrons. It producing that current. How to measure that one? See, before we are not using battery connections, we are not operating, even though we can able to measure that current. That is because of the sun rays, monochromatic rays, or you can say electromagnetic radiation, anything. Here with the help of the ammeter we can able to find out the photoelectric current. Then we have to study that one, and we got many laws from the photoelectric effect. What are those? We are discussing now. Look here. First one is the work function. What is the work function? The minimum energy required to liberate the electrons from the emitter or from the photosensitive metal, that is called the work function. When light falls on this, what happens? We require minimum energy to liberate that one, that is called the work function. And you look here, work function formula is H nu naught. H is the Planck's constant. That Planck's constant is how much? 6.6 into 10 to the power of minus 34 joules second. that is the Planck's constant. Here nu naught, what is the nu naught? Nu naught is the threshold frequency. Threshold means limit. Below that threshold frequency, we require minimum frequency to conduct this experiment, that is called the threshold frequency. Below that there is no photoelectric effect. Above that only we can able to conduct this experiment. That's why this is called the threshold frequency. It should be right hc by lambda naught also. Here lambda naught is the threshold wavelength. See, the maximum wavelength is required to conduct this photoelectric effect is called the threshold wavelength. So here hc value, it is very useful. hc value, you remember that here 12,400 electron volts angstroms. Electron volts angstroms. While doing the calculations, it's very useful for you. Suppose we are doing one problem. If lambda naught equals to 4,000 angstroms, find the work function. How to find the work function here? Simply you are taking hc is the 12,400 electron volt angstrom, but the given data lambda is 4,000 angstroms. Angstroms cancel, 2 zeros are cancelled, 4 10s are 4, 3s are 31. So answer is how much? Phi naught equals to 3.1 electron volt. See how it is simple. If we are starting there in exam, h value, c value, it takes more time like that. So better you should remember that hc equals to 12,400 electron volt angstrom. Electron volt angstrom. 1 angstrom equals to 10 to the power of minus 10 meters. Anyway, this is about the work function, and you know what is the threshold frequency and what is the wavelength also. Then we are going to discuss about, look here, we are using one external battery here. We are increasing the potential. Then what happens? Automatically number of photoelectrons also increases. Then photoelectric current is also increases. Look here, potential we are taking on x-axis. This current we are taking on y-axis. When potential is increasing like 1 volt, 3 volt, 4 volt like that, automatically current is also increases. After this is called the saturation current. Even you are increasing the potential, there is no change in the current, that is called the saturation current. Then from this you can give the relation between intensity and not from that. Generally one of the law from the photoelectric effect is intensity is increases, photoelectric current is also increases. Photoelectric current does not depends on the frequency. See, suppose you are doing this experiment morning and afternoon, that light intensity is more during the afternoon. So we will get more electrons during the afternoon. So you remember that intensity is directly proportional to the photoelectric current. Then here battery connections, when we are reversing. See, emitter we are giving to the positive of the battery, then collector we are giving to the negative of the battery, and we are decreasing the potential. At particular potential, current is 0, that is called the stopping potential. Look here, reverse we are doing. So wherever the electric current is 0, that particular potential is called the stopping potential. So all these belongs to the laws of the photoelectric effect. Then we are going to discuss about, see, frequency. What is the effect of the frequency? When frequency is increasing or decreasing, there is no change in the electric current. But which is changing here? So kinetic energy of the velocity of the kinetic energy of the liberated electrons are increasing. If more frequency, more kinetic energy. Less frequency, less kinetic energy. So it is affecting the kinetic energy. So you can say that frequency is directly proportional to the kinetic energy. Like this is the study of photoelectric effect. It was discovered by Leonard. That's why this is called the Leonard's experiment. And from this, finally we got one expression, that is the work function, that is hc by lambda naught. Then after this, immediately we are going to the Einstein's photoelectric effect. So 90%, in that 100% from this chapter, 70% problems are from the Einstein's photoelectric effect only. Remaining 30% are belongs to this concept questions. Then otherwise de Broglie wavelength, that one, from that we are expecting. Look here, Einstein's photoelectric effect. Photoelectric effect. What he explained that energy is coming like a small energy packets. That electromagnetic radiation he considered as a small energy packets. Those are called the quanta. and he said that energy E equals to h nu, and it should be right hc by lambda. This is the wavelength of electromagnetic radiation. H is the Planck's constant and c is the velocity of the light. Here nu is the frequency of that radiation. So whenever this energy is coming, when it falls on this, it is utilized into two ways. A part of the energy is utilized to liberate the electrons, nothing but work function, and remaining is to give the maximum maximum kinetic energy to the liberating electrons. This is how to write this equation. E equals to a part. First part is to liberate the electrons, nothing but work function. Second one is the maximum kinetic energy. Then instead of E, we are writing h nu. Instead of phi naught, h nu naught, and this is the half m v maximum square also we are writing. From this Ke maximum depends on the situation. You can use, if you know phi naught, directly you can use. If you know nu naught and nu, you can go through this one. If you want Ke maximum means we should write it h into nu minus nu naught. And it should be right instead of nu, c by lambda minus c by lambda naught. Finally, Ke maximum equals to what we are getting, hc into 1 by lambda minus 1 by lambda naught. Always you remember that work function depends on the nature of the material. It does not depends on the frequency, intensity and all this. So it depends on the nature of the material. We are doing one problem here. Find work function of the metal. But they are giving first one E1 equals to 40 electron volts. Next time the energy is the 20 electron volts. Maximum kinetic energy is the 2 electron volts. And here second case maximum kinetic energy is the 4 electron volts. How to do this one? Directly you can go through this one. So phi naught is constant. So instead of E, we can take it instead of E1 40 electron volts equals to phi naught plus kinetic energy 2 electron volts for equation number 1. Second one, 20 electron volts equals to phi naught, same metal means same work function, plus this is 4 electron volts. Then we can go through the ratio. This electron volts cancel, this is the 2 and do the cross multiplication. 2 phi naught plus 8 electron volts equals to this side phi naught plus 2 electron volts. So better you should take here 10 electron volts, then easily we are getting here. First one is the 10 electron volts. Then when it comes this side, what we are getting? Phi naught equals to 2 minus 1 is the 1 phi naught equals to, this is the 2 electron volts. Most of the problems are like this only. We can find out the work function if they are giving the questions are like this. This is the Einstein's photoelectric effect. From this we can find out the frequency, wavelength and whatever the situation and whatever the problem, you should deal with the help of this concept. Then we are going to discuss about de Broglie wavelength. You know that the first person who given that relation between matter is having the dual nature, and he has given one expression, that is wavelength equals to lambda by h, lambda by moment. Lambda equals to de Broglie wavelength, lambda equals to h by p. See how you are writing this expression. We know basic formula is h by p. Instead of p, we should write it mass into velocity. Instead of momentum, in terms of kinetic energy, you know that Ke equals to p square by 2m. Then p equals to how much? Under root 2m into kinetic energy. So 2m into kinetic energy. But here kinetic energy is provided by the electric potential. In terms of electron volts also we should apply. So h equals to under root 2m into electron volts. See, this is mass into velocity. This is mass into kinetic energy. This is mass into EV, means here V belongs to potential. This is the V belongs to potential. So like that, and not only this one, in kinetic theory you know that Ke equals to absolute temperature Ke equals to 3/2. In terms of absolute temperature also we should express this one. See, we do one problem based on this. If H equals to, you know that M is the 6.6 kg. Just I am giving one example. V equals to 0.5 meters per second. Find the wavelength. Means lambda equals to H by 6.6 into 10 to the power of minus 31 by 6.6 into 0.5. This one cancel. 10 by 5 is the 2 into 10 to the power of minus 31 meters. Like that we can able to find out the wavelength with the help of any formation you can find out. So this is the de Broglie wavelength. So it is very simple chapter. So you should focus on Einstein's photoelectric effect, and we should focus on like a wavelength of this one. Just now I have written this lambda electron is there. So wavelength of the electron is how much? 12.27 by under root V. 12.27 by under root V. Otherwise it should be right 150 by V. 150 by V angstroms, like that we can express this one. See, suppose if V equals to 75 volts, then how to find out the lambda of that electron? 150 by 75. So under root 1.414 angstroms, like that. So that is depends on the situation. Deuteron is there, alpha particles are there. So everything we can able to find out with the help of this concept.